All right. Good evening, everyone, once again, and welcome to another session of Blockchain UNN's Bootcamp. For today's class, we have Chidera Onwuatu who'll be taking us on how to on a practical class to sorry about that on a practical class to building your first crowdfunding app, and I promise it's going to be a lot of fun. So please, if you know it's your laptop, try to get it and join the call. Of course, as always, the recording is going to be made available, and you could always reference that later. But I'll advise you code along during the class, so in case you have any questions, you could probably ask it and also get answers. And okay, Chidera, I think it's over to you.
Okay, good evening, everyone.
Yeah, good evening.
So today we will be doing a practical class. I'll be taking you guys on a tutorial on how to build a decentralized crowdfunding smart contract. So the smart contract is going to look just like GoFundMe. I believe most of you must have heard about GoFundMe, but instead we are using a smart contract. 1 second, let me share my screen. So I believe you all are familiar with the basic concepts of Hardhat, or is it Foundry? Hardhat, right?
Yeah, Hardhat.
Okay. So I believe there should not be any difficulty on that side. So so for this decentralized smart crowdfunding, first of all, let me just give you a brief explanation of what the contract is going to do. So just like how a normal crowdfunding app works, you can go into a platform, create your project, like initialize your project. Say you want some kind of contribution for a particular cause, maybe to get a laptop or pay your school fees or anything. You have a target amount that you want people to contribute to. You have a start time. You have when it's going to expire, and yeah, that's basically it, and maybe a brief description of the project. So for this particular one, it's going to have all these functionalities, and um, I would also like to implement maybe an additional thing to it, whereby whenever someone wants to contribute to a particular project, right, the smart contract will automatically mint an ERC20 token for them. So let's say some Tochukwu created a project. He's gathering money to he's trying to gather money for his maybe house rent or something, right? And I go and contribute. I go and contribute to his project. I The smart contract automatically mints a reward token for contributing to his project to me. So that's basically what the contract is going to do. So we will have two contracts, right? Um, One is going to be the ERC20 contract, and the second one is going to be the crowdfunding contract itself. So this contract is good because it's basically going to encompass everything that we've been taught so far, and you are going to see everything in action. Yeah, let's just move ahead into the Hardhat installation actually. So I believe everybody has Hardhat in their system. So we just have to go straight into um, Yeah, we'll just have to go straight into starting up a new project actually. Let me create. So to kickstart a new Hardhat project, this is basically the command npx Hardhat, and we'll be doing a JavaScript project, and inside of this current directory, yes, we need a git ignore, Hardhat nomic, yeah. So yeah, we're basically going to accept every of the question, just yes to everything basically. So it installs all the dependencies that we would need. I hope the whole thing. I think, did somebody ask any question? Okay. Is it better now? Hello, the person that asked I should zoom in. I hope you guys can see my screen.
Yeah, still can't see no, sure.
Sorry?
Like I can't see the command.
Oh, so the only I just created a directory on my terminal. Then I did the npx hardhat on that directory. So it initializes a new hardhat environment for me.
Okay.
Okay, so I believe it has installed everything that is needed, and I just have to open it here. Like so. Okay, so just to quickly go through everything in Hardhat, this folder is basically where all our contracts are going to go into. This is just the node module. I believe we all know what that thing is for. Then this one is like for scripting, writing your deploy script and basically writing scripts to interact with your contract. Then this one is your where you put in your testing scripts, git ignore, then the other ones. So basically, in Hardhat, right, you have this config file where you like configure the environment for your Hardhat setup. So this is basically where you write your configuration for your network configuration for the compiler itself. And I think there's something missing. Okay, yeah. You also have to have your .env file where you are going to put in your private keys, your API key, and your node um, URL. Basically, it's the node that you use in it's the node you use in interacting with a live network. Um, Let us start with this one. So first of all, we want to configure the Solidity compiler. So here we have the version 0.03. Um, 1 second. Need to configure some. So here we have to configure the version. Let's say we want to use 0.8.20. And maybe additional settings. Basically, all these things are still the same thing with what you have on in your remix. So this one is just for the optimizer. Enabled keyword true. You don't really need to actually know this part. It's not that important. It's just for the machine itself. But you can read the harder documentation to see what exactly it does in depth. So after configuring the Solidity, we want to specify our network. For today, I'm going to be deploying to Sepolia. Or should we deploy to Matic? I just deploy to Sepolia. But Matic can be unstable sometimes. Um, so Hardhat, I believe Hardhat network. And, one second. Hope you guys can see my screen.
No,
Hello?
I can't see your screen. I can't see your screen well.
Huh?
Like you need to make it bigger. Can you make it like this? Like I don't know this. What's it called? Um, like just make it. Yeah, yeah, yeah. It's okay now.
It's better now, right?
Yeah, yeah, yeah. Sharp, sharp, sharp.
Okay. So we want to configure our Sepolia environment. For the
Hello,
Sepolia
sir.
environment, basically the Sepolia network, sorry, you need a URL. You need a URL and you also need an account that should be connected to it.
Hello, sir.
Yeah, I can hear you.
Sir, in my Hardhat config file, my own Solidity, the version is coming out as 8.19, but yours is 8.20.
Yeah, you can configure any version you want. Just make sure that whichever version you put here, it falls within the version in your contract, right? This one is
All right.
using 0.8.9. So in your compiler, you should make sure that it's at least it's above whichever version is specified here, because this thing means this version and above. You understand?
All
So
right,
make
sir.
sure you configure it accordingly, unless or else you keep getting errors. So for the URL, it's important you put all those things inside of your env file. But before that, let us install .env. So it helps us catch our values from our environment variable. Just npm install .env. You know how to call the .env stuff into your file. That's what they require. Command JS .env config. And that's all. Now for the .m file, I'll need a couple of things in the .m file. I'll need my URL. I'm going to need my private key, the private key to the addresses that I'm going to be using in deploying and interacting with the contract. I also need an Etherscan API key, right? And which other thing do we need here? So the URL, private key, and Etherscan API key. That's basically what should be in your URL in your M file, right? And that's all. Let me stop sharing my screen quickly. So I'll go copy my private key and other things. I cannot show it here on Discord, but you guys use the time to do the same thing. Actually, 1 second. Okay, let's continue. You can see my screen, right? Okay. Anyway, I already imputed my private keys in my .env file. I've inputted the URL and the Etherscan API key. These are what we'll be needing to configure the network and Etherscan for verification purposes. So I'm going to get a hold of my private keys here. I want to destructure them actually. And the URL itself. So let them set of time. And so to capture the URL, I'm basically going to call it like so. I'm basically using so I'll be using Infura. It's up to you whichever node provider you want to use. You could use Alchemy, you could use Anchor, you could use Moralis, whichever one you feel is okay for you. Just make sure you are using the Sepolia link for it actually. So I'm going to tag in the URL here. And for the account, I'm just going to pass in the account I've destructured above. And that is it for the Sepolia network. So I believe after that, we'll have to configure Etherscan as well. I just need the API key. So I believe you all know how to get this API key and all this the URL and your private keys, right? If you are confused, please let me know before we go into the coding. These are the basic things you need to get done before you start coding.
Sorry, can you still zoom in?
Are we there?
Please, can you paste your config file so that we can use it?
All right. I think I'll have to paste it in the chat. So that's it for the Hardhat config. We set up our env and what else? So we don't need this file. We'll be deleting it. Like I said, we're going to be writing two contracts. One contract for the token and another contract for the so another contract for the crowdfunding contract itself. So let's just write the what token. And remember what I taught you guys about interfaces? We'll basically need the interface of our ERC20, so we'll be able to call the functions on our charity and some kind of inheritance on the token itself. So let me quickly get an interface folder here and maybe an interface. Let's load. You can basically call all these things any whatever name you want. So let's basically start coding actually. Let's write the contract for the token itself. So this is pragma. We want to specify the version. I want to call it 0.8.0 or use 0.8.2. So this one I'm saying anything from 0.8.0 and above. So this should also capture it. And we are not going to be writing ERC20 from scratch. We're going to be using OpenZeppelin's library. So let's install that quickly. I've forgotten the code that. So we use this code to install OpenZeppelin. Okay, it's installed. Now I want to import OpenZeppelin. I want to import two things basically from OpenZeppelin. First, we want to import the ERC20 contract. I want to also inherit from the ownable contract. Um, okay. Supposed to be inside. 1 second, please. Okay. I want to also import the ownable one. So basically, what the ownable also does is just to it helps us just to capture um the address of the person deploying the contract. So that way we're able to know who the contract owner is. We basically need it for some kind of functionalities. So we should be importing that one as well. Before we continue, let us first write the interface. So for this interface, what are those things that we need? What are those basic functions of ER? Have you guys been taught ERC20 here? So, can you guys hear me?
Yes, sir, we can hear you. We've been taught here as
Yeah,
a
yeah,
trade.
yeah. We've been taught here as a
So,
trade.
so what are the basic, what are those functionalities we need for the ERC20?
We need transfer from function.
Okay, what other one?
Approve.
Okay, I think for now those are some of the. Please kindly pay attention. If there's any place you are confused, just let me know as we code along, because I'll do the first part and you guys would have to extend it further for your assignments. So these are the events, right? Now, for the functions that are callable by this, for the function that will be callable by any inheriting contract, we need the total supply. And remember how libraries work. You just need the function declaration, nothing else. So the total supply is supposed to return a UN256 because we don't know what the total supply would be. And we also need um, we need balance of, we should take an address. So it helps us check the balance of a particular address. So I believe you all know why the transfer function is supposed to return a boolean. For the allow ones, takes in an address, owner. Basically, this function helps you know the amount that a particular address is allowed to spend from your account. So that's basically what some of these decks is. That's basically how they operate. Before Uniswap is able to transfer any amount of money from your wallet, you must have given it. You must have approved Uniswap to be able to spend certain amount of tokens from your address. And once they spend more than that, up to that amount, they would ask for another approval. And that's one way to put it actually.
Hello, sir.
Let's be go. Anytime. So we have total supply, balance of transfer, allowance, approve. After approve, I think all we need now is means. We need the means function. To close your distance. So we need the means.
Hello, sir. Question.
Yeah.
Sir, please, why does the transfer function need to return a boolean?
So you can use it to you know if there is any error with the transfer. Let's say you're supposed to you're supposed to call a transfer, you're sending to a particular address. If it does not go through, the boolean is going to return false for you, and you can use it for further computation in your code um, in case the result is false, right? You can use it to do some other manipulations you want in your code.
All right, sir. Thank you, sir.
So for the mint, we want an account and we want to set amount. And no, address to settings. So it's returning. Okay, let's continue. If it throws any error, we'll come back and check it. So we'll have to import this into our ERC20 token. So we can use those functionalities actually to can use it to start editing some of the functionalities there. Interface design this. Contract. Let us call it charity. Okay, let's ERC20. Remember what this is keyword. What it does. And I taught you guys about inheritance. So whenever you use this is keyword, you are basically inheriting all the functionalities of this and this. That way, your contract automatically has every functionalities that are specified in each of these contracts. So now, one important aspect of writing smart contracts, software development actually is like you need to plan appropriately. What exactly do you need your contract to do? First and foremost, this ERC20, it should only be mintable by um, it should only be mintable by the contract, that is the charity contract. So people cannot just go on Etherscan and call the mint function. The only account that has the power to call that mint function is the charity contract itself, right? And I mean, basic economics in tokenomics, it should have a maximum supply. If you want it to have an infinite supply, that's still up to you. So that's basically it. So let's see. You want to have an address, should be private, so nobody knows who the main scholar is actually. This one main scholar is the address that should be able to call the main function. Excuse me. So this is the UN256. For this one, I'm going to make it private. This is my own design decision. You could decide to use something else. If you want to make it private or public, it's still up to you. I don't want anybody to know. So you have your address, which should be the platform. Basically, this should be where maybe the owners of the platform or something. Should we add the owners of the platform? Let's leave it for now. Let's just move on. So creating the ERC20, you should have a constructor function. Since we are inheriting all the functionalities of this ERC20 provided to us by OpenZeppelin, we just need to use the constructor to build our own. So in here we have, I think, okay, is it yes, it 20. Right. So I think here you have to name of the token and the symbol. So let's sigma supply should be 10 to 3 and to 3. Okay. Um, times 10 raised to the power of this decimal. Basically, the decimal is usually raised to the power of 18. That is why we are timesing it by 10. So it gives us this value in base 18, or raised to the power of 18. Because if you should just make the maximum supply to be this value, it's going to count backwards. I don't know if you guys must have been taught about this during the ERC20 class. You just have to, for the total supply, you just have to multiply it by the decimal. So it displays appropriately on the front end. Then like I said, we want only a particular address to be able to call the mint function in this contract, right? So how do we do that? Are you guys with me?
Yes, sir, we are with you.
So
We can use the require functionality.
huh?
We are with you, sir.
So how do we make, so we want only the
Please, I have
mint
a question.
caller or this address to be able to call the
See,
main function in this ERC20. So how do we do it?
Sir, we can use require to take the address calling if it's the address of the platform or the mint call or something.
Oh, okay. That worked well. I think using a modifier is better in this case. Instead of having to be doing require every time, that takes gas. It's more efficient to do um, all the validations in a modifier function. I get you guys will you come to that. I think you get to gas optimization very soon, but it's important you know on time. So let's go this one only means right, and you want to require msg.center. Hmm?
Hello, sir. Question.
Yeah, go ahead.
Sir, please, I can't understand what you said in line 12 and line 15.
Inline what?
Line 12 and 15.
Okay, so the line 12 is basically the address, the platform address, maybe your own address, like the owner of the charity or something. You understand?
All right, sir.
The mint caller is like the contract address of the charity itself. So here we want to require that, want to modify, we want to create a modifier such that it is only this person or the contract that is able to call that mint function that we're talking about. Then here, this one is just about your basic ERC20 supply, right? If you want to do a supply of, let's say, 10,000, you want to do 10,000 times this 10 raised to the power of whichever decimal you want your ERC20 to be. So by default, the decimal is 18. It's usually raised to the power of 18. This thing is important because we do it like this because when you are, how many of you have used Trust Wallet?
I didn't get that. Could you try again?
You guys must have used the Trust Wallet or MetaMask, right?
Yes, sir.
So if you want to import a token, if you want to import an ERC20 token into MetaMask, it will ask you for the token address, the name of the token, and the decimal of that token, right? Now, it is that
Yeah.
decimal that your MetaMask or your Trust Wallet will use and know the actual supply of that token to help them in doing the mathematics of adding and subtracting. If you should put a wrong decimal, then the total supply is not going to be what you think it should be. So that's why it's always important. You can read up the Open Zeppelin document to better understand how the doc and how the decimal works.
All right, sir. Thanks, sir.
You're welcome. So we want this thing to be the energy that will send out of this function to either be the main caller or the sender and the path.
Um, Good evening, sir.
Yeah,
Hello.
I can hear you. Go ahead.
Yeah, please. My network was breaking when you were explaining the private mint collar and the platform stuff. So I could not get what you said. Please, can you just throw more light on it? Thanks.
Okay. So so what I was saying is okay, the platform and the only mint caller, right? What I was saying is in this place, in this mint caller variable here, this is basically the contract of our charity token. When we finish writing the charity token, we deploy, it should give us a contract address, right? Now, the contract address is what we are going to save to this variable. And the platform, we want the platform to be whoever that deployed this particular smart contract, which is going to be the platform. You can name it maybe platform owner or something else. You understand? So now we want only these two addresses to be able to mint tokens to the charity participants. So anybody that comes and deposits or comes and support a particular cause, right? We want the contract to automatically call this the mint function on this ERC20 contract and mint that token to the person that has contributed. That is basically what we are modifying here. So we are creating a modifier function here that is requiring that the msg.sender should be the mint caller, which is the smart contract of the charity or the platform owner. If the caller of the main function is none of these, then it should throw this error, unauthorized caller, right? So that's basically what I was explaining. Then after writing your modifier, you should always do this. This basically tells the modifier function that okay, for every function that is trying to call you or that is trying to use you, run this line of code. After running this line of code, continue with whichever other code that is in that function. That is basically what this thing is all about. Then I think that should settle it. Let's move on to the functionalities now. So for the first function, we want to pass in mint color, right? Let us set mint color. If you set the mint color, you should take in an address, right? Of mint color. And after taking in an address of mint color, you want it to be public. So you can set your mint color after you must have deployed your contract. Because at this time, at this point in time, we do not know what the contract address of this charity contract of this charity contracts. We don't know the address of the contract yet. So we cannot explicitly set it here. That's why we have a function that is going to be callable after we must have deployed this charity contract. If it's something that you know about the create to and the create functionalities, where you can basically predetermine the address of your contract, then you do the whole computation and pass the contract address here. So for now, I mean, those are very, very advanced concepts. Let's just stick with more intermediate concepts. Right now, we don't know what the contract address is going to be. So you cannot actually put any address here. We have a function that is going to be callable by the owner, that is going to be callable by the contract owner to set the contract address. So let us require that sender equal to the platform. Remember, the platform is like the owner of this both the token and the both the token and the ERC, both the token and the charity contract, sorry. So we want to require that anybody calling this, the only person that's anybody calling this particular function, we want to make sure that it's the platform which is the owner of this ERC20 token. That's basically what the require statement is doing. Then if the require statement passes, we want to set the mint color to equal this mint color, right? So this automatically sets whatever address we pass in here into this variable, and then this should be active. Then let us get the decimal. Let's set our own decimal actually. So we want to do public view returns it. Now remember that this decimal, is a functionality from ERC20.sol. Because if we should go to ERC20.sol, 1 second, this should be highlighted. I don't know why. So if you should go to ERC20.so, you see that this is a function. And whenever you want to, in any way, if you want to override or like make edits to the functionalities in a particular contract that you are inheriting, remember I told you guys that you need to put the virtual keyword on your function. So this one, we want to override the decimals. I think I made a mistake here. 1 second. Not decimal, should be decimals. So we want to override this decimals functionality. Here it has the virtual and override. So we need to put the, I think is it override keyword here. So we'll be able to successfully change some functionalities in here on our own. So let's return this to be. So that's that for that. Then the next function, I want to get the let's get the max supply. Yes.
Hello, sir.
Yeah, I can hear you.
So I thought that the decimals, like naturally it returns 18. Why are we now overriding it?
Yeah, I was just doing that to like explain the the concept of overriding in case any of you want to like change 18 to something else. This is just like by default, right?
Yes, sir.
ERC20 by default are 18. But I mean, if you want to create your own token and say, okay, oh, I want my own decimal to be 8 or I want it to be 12, then this is basically how you do it. You understand?
Yes, sir.
So you could make it to be 12 or 11 or whatever. It will still work, but it's going to be a little bit different when you want to add your tokens to some of those wallets. Instead of specifying decimals as 18, you should put it as whatever is being returned here. So
All
for
right.
this one, I want to return max supply. Set mint color. Okay. We've not done mint yet, sir. So here we have the mint. We have the address. You want to mint to an address, right? And you want to mint a particular amount to that particular address. So in the mint, since we want only the platform owner and the charity contract to call this mint function. We'll pass in the modify functionality here. So have the require that have this stuff. So for this mint functionality, we want to do some kind of check each time we want to mint a token, right? And we want to make sure that total supply, I have total supply here. Okay. So the amount that is being minted is less than or equal to max supply. So this basically makes sure that it basically makes sure that the total supply that the total supply of our ERC20 token is basically whatever we anytime I want to mint a new token, it's always below the total supply. This enables us not to mint above the total supply. Then I want to use the super keyword to call the mint function. Into this account and we are minting this particular amount. So the super keyword just helps us get into use the mint functionality that is inside of this ERC20. You understand? So if you go to the ERC20 documentation, this is the mint functionality. This is everything inside of the mint functionality. This one is an internal function that helps us do the whole calculation to make the transfer, right? And remember that ERC20 are just numbers. You are just plusing and minusing. So in this call, this super, it helps us get into the functionality that is in our parent contract. Once you get into that functionality, you do use the dot, then call whichever function you want to call, which is that internal mint function. So which other thing again? I'm writing my smart contract. I like to make it a little readable and separate all the functionalities. So the ones below are basically your view functions where you can use to get information on the contract. Then the ones above are basically the the smart contract from functionalities, the ones that modify the state of the contract, right? So with this, I think our reward token is done. And again, I think it's good practice to always name your file the same, give your file the same name as the contract. I'm not sure if that still applies, but sometimes it could give some kind of errors. So it's always important you give your file name the same name you give your smart contract, right? Are you guys with me?
Yes, sir.
Yeah. So you give
Yes,
your
sir.
token the same name you are giving your contract. You should have the same name as your file. So we are done with the reward token, and let's move on to we've done the interface, we've done the reward token. So we're moving on to the charity contract itself. Um, so let's move on. The first step to writing your smart contract, like we all know, is to specify your Solidity version. Use the normal convention of
Hello,
0.8.0
please,
to avoid
can
problems.
you hear me?
Yeah, I can hear you.
Please, can you just go back to the interface token contract? I just want to glance through it and see interface token, interface dot so. Sorry.
Interface.so.
Yeah, interface dot so.
Okay, okay.
What? Okay. All right. Thank you.
Yeah. So for the contract, right, we need to somehow keep track of every single project that people are creating on the platform. Sonto could create a project, I could create a project, Musa could create a project, Ahmed could create a project. So we need a way to keep track of every single project that is being created on our platform. And for me, I like using one of the libraries provided by Open Zeppelin, which is the counter library. So we want to get uh, ERC20, ERC20 instead of the utils, we want to get the counters. So this is basically a library provided by Open Zeppelin that helps us keep track of um, basically numerical values in our contract. It helps us with counting. You can decide to do this manually on your own, where you can maybe for every function call you are iterating over your, maybe you have a state variable of 0, and for every new project that is being created you could increment it by 1, 2, 3, and saving it to some struct. But I mean, these are already audited libraries, and it's safer to use it instead of having to write things from scratch. So we want to import the interface. We also want to import the instead of the contract, we want to import the token itself, because we'll be using these two things in our charity contract. So as usual, to create a contract, you want to the contract keyword and then charity, which is the name of your contract. Like I said, we are going to be making use of this library to keep track of counting, and those numbers we are going to use them as an ID for each of those projects. So each project that people create will be assigned an ID, and that's the ID we'll use to be keeping track of each of those projects. So remember to use this library. You can use the using keyword counters for counters dot From their documentation, this is basically how we use the counters. You are basically going into the counters file and you are using the counter contract. Um, we also want to get the I reward token, which is the interface, right? I reward token, yeah, which is the interface of the ERC20 token we'll be using basically. Then this should be private actually. I want to call it the charity token. And the next thing we need to do is so for these counters dots, no, my keyboard is doing. The counters dot counter.
Excuse me, sir. Hello, sir.
Yeah, I can hear you.
Excuse me, sir. Please, the interface, did we manually wrote the interface ourselves or we imported it?
We
Because
imported it.
sorry I joined late, so I was not there when you guys were
So
doing the interface.
okay,
You
so for the
imported the interface, so it brought all these methods with
exactly,
it.
yeah. So we have a folder called interface and we specifically wrote out the functionalities that our smart contract, that is the charity token, will be calling. So interfaces like it gives you a kind of uh, set of functionalities that are callable by a particular smart contract, right? In this our interface, we will definitely need the total supply. We'll definitely need the total supply of we need the total supply of an ERC20. We need the balance of transfer, allowance, approvement, transfer from, all those things. That's why we specified all these functionalities. And these are the functionalities that our smart contract is going to be using when minting these things to people, these tokens to people. This interface does not only apply to ERC20. It applies to every contract. Anytime you want to interact with any contract, you just specify the specific functionalities you need, and then you use it to start interacting. I don't understand the interface. That's what I just finished explaining. Ezekiel, did you join recently? Hello. Anyway, I believe the interface is, just take it as um it provides like a set of functionalities that a particular contract has. So like an ERC20 token, we all know
Sir,
that.
can you hear me?
I can hear you.
Please, can you show us your interface and solidity file so that I can replicate the code?
Interface what?
The interface code, I want to write it, please.
So this is it. This is basically it. So like I was saying, like interfaces, they basically, it's just like it helps you like specify the functionalities. It shows you the functionalities that are callable in a particular smart contract. In this our charity contract, we want to do what? We want to interact with an ERC20 contract, right? Which basically helps us mint token to contributors. So that's why we're specifying an ERC20 here, which gives us like a skeleton of functions that are callable by our contract. Our contract can call the balance of, it can call the transfer, it can call the allowance, it can call the approve, and it can call the mint and transfer from, whichever one we need. We specify them there, then we import into our main contract file and start calling the functionalities, using those functionalities to make computations. So that's basically. Let me just. If
Sorry, sir. So we did not write any of these functions in the interface.
I don't understand your question. Come again.
I said, since we imported the interface from OpenZeph, so did we include our own custom function there?
No, no. We did not import the interface from
So all
OpenZeppelin.
those functions were the functions
This interface,
imported.
this is basically the code we wrote. It is us that is writing it. Are you with me? This interface,
Okay,
we
okay.
wrote it by ourselves. You understand?
Oh, that was what I
Then
was
we are
asking. I thought you said,
no. We wrote it ourselves. The only thing we are importing here is the counters, which is like a library that OpenZeppelin has provided for us. Basically helps us in counting, like incrementing value. That's the only thing that we did not write by ourselves. Um, yeah, so that about that. Um, so these counters, we are using it to keep track of every project ID. Then we also want to specify an address here. The address should be public and it should be the platform. This address should basically be the address that is deploying the smart contract. You understand? Which is basically the owner of the ERC20 and the smart contract itself should be our own address. But we'll set that later. So for every, like I said, for every project that is being created on the platform, we want to have all the necessary information concerning that project. And to do that, we basically use the struct to keep track of every project information. You guys should remember what I taught you about struct. So yeah, so we'll have to specify some values inside of this struct, which every project should have, right? And one of those values is address, should be the creator. Every project should, we should be able to capture the address of whoever that created that particular project. That's basically what this one is saying. Then we should have an array of addresses, right? An array of addresses that keeps track of contributors, right? Someone creates a project and 10 million other people contribute to this project. We should be able to keep track of every single contributor to this particular project. Then the next thing is a string. It should be a string, and I believe we should have a name. A camel casing for clarity. So the project should have a name, maybe school fees or rent or anything. It should have a name, have a string, let's just say an image. This is basically it will be useful when we get to front-end integration, because in the front end now, this image, when you upload an image, you want to get the CID from IPFS, and it's that CID we're going to pass into our function and store on the blockchain. So in the front end, we are seeing an image on the blockchain. The image is being kind of converted into a CID by IPFS or whichever file system you choose to save it into. So we also have a string of description. Tell us about your project. What's the project all about? Should be a string value. We also need which other thing? Creator, contributors, project name, image, description. Which other thing should we be saving? Yeah, we also need the goal, which is a win 256, right? Basically, it's just like how much do you want to raise for your project, right? That's basically what this thing is keeping track of. Maybe 100 ETH or 20 ETH or 10 ETH, anyone. After that, we also need So we need to capture the current time. Current time and current amount, sorry, the current amount that the project currently has. And the, 5, 6, we need to know the start time when the project goes live. We need to capture when it has started, so we may be able to make estimates, be able to calculate the end time. Um, so the start time is going to be the block dot timestamp, or the user is going to specify when their project should start. Then the end time is basically going to be specified by the user. So you are creating a project that you want to gather money for your rent, and it should be expiring in 2 months. You pass it in there. Which other thing? Okay, we need a bool capture is started. We need another bool to capture is closed. So this is it will basically help us. It will basically help us keep track of the project and know if it has started, or if it's still running, or if it has ended. That way we can stop people from contributing if a project is no longer active. Then after creating the struct, right, we need to have a mapping. Like I said before, I want to keep track of every project. I want to keep track of every project ID, right? So what we need to do in this mapping is to map an ID in 256 to this struct. This struct is going to be public. Call it project. Just call it project. Sure. I'm very bad when it comes to naming. So after that, after the mapping, like I believe you all know what mapping does. It just helps you to map keys and values together. For example, Sonto creates a project. He's the first person that creates a project. Automatically, this counter is going to increment, and his project is going to have number one, and that number one is now mapped to this struct here with all the information that Sonto has filled in. If another person should create another project, the second person is going to carry number two, and that number two will be mapped to this whatever he filled in here. So mapping is a way to it's like a hash table. It maps certain values to another certain information. It's just like somehow like arrays, where array you can use the index to like capture certain values also. So on the state variable, we want to have the total projects. To help us keep track of all the projects that are in the platform. So you want to also have an array public, and also the projects. And then this one is up to you. It depends on what you want to do, but I always like having um, so it's not really necessary, but I just want to capture basically everything that we've been taught in class. It's just platform fee. So I mean, whenever anybody wants to withdraw their earnings, right, we should be able to take our own fee. We should be able to take our own percentage from their earnings. So that is it for the state variables. For the, I think, what's next? Events. It's always good practice to have events. So what event do we need? We need event of a project. When a project is created, it should emit an event, right? This is basically going to help us to get certain information and help in front-end integration. So when a project is created, we need to capture the project ID. We need to capture the creator of that project. We need to also capture the amount that they want to raise. Okay. Once every people, whenever somebody contributes to a project, once we also emit an event. Okay. We need to know the particular project that was funded. We need to know the person that has funded the project, who is the contributor. We also need to capture the amount that they contributed. Anytime a project has closed, we need to capture the project ID of that project. Whichever project has closed, we need to know the ID of the project. Then we need to get into the Boolean, true or false. And lastly, when a project creator withdraws any of their contributions, let's say they've made, people has contributed to their cause and they've reached their goal, they want to withdraw their earnings. Whenever they withdraw, the contract should emit that event that, okay, oh, he has withdrawn his money. Contributions. Withdrawn, taken, withdrawn. So, in 256, the project ID, just paid. So, and we want to know who paid to. We want to know who, like the person that received the payment. Amount, the total amount that they received, and the total amount that the platform received as well. I hope we are all together. Is there anything confusing to this point before we go into the functionalities? Hello? Are you guys with me?
Yeah, yeah, we're with you,
Why?
sir. We're with you, sir.
Okay, okay. So there's no, I think time has reached, Seth. Anyway, let's just write the first function, then we call it a day. I think you guys will have to
Please, can
finish
you
the
wait
new
some
one
more?
first.
Like, slow down. I want to topic
Okay, go
two.
ahead, ask your question.
Okay, so
Yeah, ask your question. Ask your question.
Yeah, I was just saying that you should slow down, please, so that I can copy your code.
Okay. Okay. So for the first function, we want to create a function where people can create projects, right? So I'll be using anyway. Um, we have a function to create project here, and then we need for the user to pass in values into the parameter. So for the first one, we will need, excuse me, we need a string of image, right? We also need a string of the project name, which the user will have to pass in. We need another string of the project description, which the user will still need to pass in. We need a uint 256 of the goal, which is the total amount that they need for their project to be actualized. We need another uint 256 of start time. And we also need, what else do we need again? So image, project name, description, goal, start time. Uh, Project name, current amount, start time. Okay, I think we also need end time, like when they want the project to end, right? And it should be public. So this is all the parameters that the user will have to pass in for their project to be created. Now, as for safety purposes, you always need required statement in your code. So you want to require that the msg.sender, this is always very, very important. Sometimes things can happen. You want to make sure that the msg.sender is not address 0. You guys know what address 0 is, right?
Yes, sir.
Huh?
Yes.
Yes, sir.
Address 0 not allowed. So we want to make sure that anybody calling this function is a valid address, right? Then after that, we want to also require that the goal is greater than 0. The money they want to raise is greater than 0. For some, not really people, it's always important because sometimes they may want to use bots to attack your smart contracts, and you keep burning fees for nothing. So we want to make sure that at least the inputs that they are putting into the contract are valid. So we want to require that the start time it's always important you separate the naming in your parameters, especially if they have almost the same name in your struct. So you're not running into unnecessary problems. You want to require that. 1 second, please. My keyboard is. You want to require that the start time is greater than or equal to the block dot timestamp, and the end time is also greater than the start time. So the start time must be must be a date in the You guys understand what's happening here, right? Hello. Anyway, let's create a local variable here. Current project ID equal to the current project ID is our state variable dot current. This dot current is a function from our it is a function from this counters.sol. If you have time, you can look into Open Zeppelin's counters.sol so you better understand what all these things are doing. But it's a function from that Open Zeppelin's code. It helps us to keep track of the current ID in your smart contract, the current number in your smart contract. So for this one, basically, it's 0. So it helps us know that okay, um, this is the first ID. Then after that, you want to remember how we initialize struct. We want to go into the storage, call that struct there, and then use it to initialize a new local variable here. So we'll be able to edit information on there. So this is going to be projects. I'm using the mapping to assign this thing now. Current project ID. So remember, this is going to get the current project ID for us using this counters function. When we get it, we are now using that value, putting it into a mapping and assigning it into this local variable. Remember that this local variable is calling the wait, let me divide my screen. So remember that remember that this is this our struct. It helps us keep information about every project that people are building in our platform, right? Are creating in our platform, right? And then we are using this storage keyword. Remember, it helps us get into the storage of our smart contract. This is the storage. Struct help us struct basically whatever that is being saved in the store in a struct are being stored in the storage of our smart contract, not memory. Remember, storage is permanent memory location. Memory is just like temporary. So we are using this to get into the project storage, and then we are assigning this local variable just like a placeholder. Then we are now using this mapping. Remember, this is a mapping, right? This is a mapping, and it maps an ID to a project, which is this struct. It is mapping an ID to this struct here, right? That is basically what we are doing here. We are saving the current project ID. We are using this current to get the current number, right, for our project, and then we are saving it into this local variable, and we are now using that number that is being returned, passing it into this mapping here. We are passing it into the mapping, and then that mapping is now mapping that number to our struct. That's basically what this line of code is doing here. So after doing that, we now have access to the struct itself, and then we can now start populating the values inside of that struct based on what the user imputed. So we can now start doing project. We use the dot, and you see it as it's giving us all the necessary values. So the first one is the project.creator, and basically the project.creator is going to be the msg.sender. Second one should be where is it here? Project underscore. So the second one is going to be the project name. Project name is going to be, remember, all these things that the user is passing in is what we are passing into the struct right now. Going to be the project name, which is what the user passed in here, right? So the next one, we are going to do project dot image. So the project dot image is going to be the image passed by the front end. Then project, don't worry about this image stuff. You get to, I don't know if you guys have done anything about NFT, where you get the CID from IPFS. So the CID also represents it. So after the project dot image, you want to get the project what and description. So we have the description here. Project dot goal. Project dot goal. Remember, we are filling in whatever the user passed. We are filling it into the struct. So the project dot goal is going to be what the user specified. Hmm? Project dot start time is going to be the start time the user specified above. Project dot end time is going to be when the user specified their project is going to expire. Then when we've set all those things, which are the basic things that the user needs to pass in, we now do our project dot is started. We set it to true. You know, by default, booleans are set to false, right? Am I
Sir,
wrong?
sir,
Yeah, I can hear you.
your project from line 60 are no longer carrying the underscore.
From line 60. Hold on. Oh, thank you. That was a mistake.
Sir, another question.
Yeah, I can hear you.
When we are declaring those parameter in these create projects, memory, like data type, the storage. Why some of them after writing data type will put the storage like the image and description? Why?
The image and what? Okay. So it's Solidity's convention that whenever you are dealing with string or whenever you are dealing with string data being passed by into the function, it's important to use either memory or call data. You need to specify where the data location of that particular value. Strings, you can either use memory or call data, but it's always important to use call use memory. I think one of them saves more gas. I've actually forgotten, but you can look it up. If you are dealing with bytes, if you are dealing with bytes data, I think bytes you have to use call data for those things. So to be sincere, I've actually forgotten the reason for like when and why you should use memory against storage or memory against call data. This is just normal convention, but you can read it up. I'll send you guys a documentation to better understand those things. But just know that by convention, string when passed into functions, right? It's best you just use memory. And call data usually is being made for bytes. If you're passing any bytes data into your functions, you use call data.
All right. Thank you, sir.
Yeah. So we finished pushing all these values into our struct, right? Remember, we have a total project here. We should keep track of all the projects that are being created on our platform. It's just so front end has things to play around with, I guess, and make the front end interactive. So the total project is going to be total project plus one. You can actually do total project plus plus, but I think this one saves more gas. This one saves more gas, especially when your project starts to grow. The plus plus is more like an iterator. It will have to keep iterating, and it eats up more gas. Then for the all project array, this one is really not necessary. Just um, I want to use it and show you guys how you can also use arrays and keep track of projects. You need to be careful of your naming, so you know how to this thing that has the same name. So project array dot push. So we are pushing each of the project ID into an array, just in case you decide to use an array to maybe return certain values instead of mapping. You can also do that. But arrays, using arrays instead of mapping, I think arrays eats more gas, because if you anytime you want to interact with an array, it's more like you are looping through, you are iterating over all the values. Imagine you have over 1,000 or 1,000,000 values in your array. You keep running loops and you keep paying gas for each iteration. So that's it. That's how you use an array instead of mapping. Then after that, what did we say? We should have an event. Excuse me. You want to emit an event when everything successfully goes through. When a project is being created, you want to emit an event of project created. And in our project created array event, sorry, we have certain arguments. The first one is the project ID, which is the current project ID. The second one is the creator, which is the msg dot sender. The third one is the goal amount, which is the goal that they passed in here. All you need to do is just to pass it like so. Yeah, that's pretty much it for creating. That's pretty much it for creating a project. So I think we'll have to stop here now. I have something else to do.
Hello, sir.
Yeah, I can hear you. Go ahead.
Sir, in the total project, we did not make use of the library again. There was this library we are saying that we can use to count something in line 65.
In line where?
In line 65, like, are we counting it by ourselves? I thought there was a library so that we can use to do our accounting.
Okay. Yeah, you can as well use the library to do it, actually.
Okay, thanks, sir.
So in that case, this is the current ID for this one. You can as well put the total project here, actually. Total project equals current project ID. No, it's not going to be. I think um I think this also have another function for the increment. Not project or increments. Yeah, it has a function for incrementing value of. One second, let me confirm. It's use counters. Yeah, so it has a value to increment things. So you can increment, decrement, check for the current value, reset. Yeah, that's it. So you can either whichever one you want, basically. You can use this one to increment and save to the total arrays, or you could just do it the other way. Just play around with them so you see whichever one, whichever one that works best for you. So where are we? Yeah, we'll have to. Next one should be a function for people to contribute. Function for people to contribute. A function for that one again, self. A function that is going to get to look through all the projects in the platform and return them to you. Get close the close project function that is going to be for people to receive or withdraw contribution. As project creators can withdraw contributions. Now one more one function to set charity token address. I think these are simple. You guys can do it on your own now. Anyway, we'll continue from that from next class. I don't know if I can share this thing to the group chat yet. Yeah, then text, you can ask your question. It's too much.
So can you hear me?
After the project, I'll share the link. I'll share the GitHub link. So I think till Sunday, Abby.
Can you hear me, please?
Yes, I can hear you. I can hear you.
Before you conclude, can you go through the project and the essence, the purpose of everything, please? Like a whole recap.
A recap. Okay. So basically, we are building a decentralized charity platform, right? Something that is going to that basically does the same thing as GoFundMe, but instead of utilizing usual traditional payment systems, we are using smart contract to keep track of all the payments, all the projects, and every other important details. Our own charity platform is that one of the interesting things that kind of separates it from others is that we are giving out reward tokens to people who contributed to the platform, right? So someone creates a project and you interact with the project, you are being minted an ERC20 token. So for that, we have two contracts, a token contract and a charity contract. Before we started, we created an interface. So this interface is basically an interface itself where we specified all the functionalities of our ERC20 token, which we are going to implement in our charity contract. Then we created our own dedicated ERC20 token, right? We are inheriting the ERC20, OpenZeppelin ERC20 library here. We're also using the Enable to get the person that deployed the smart contract. We have the mint collar, we have the maximum supply, we have the platform. And basically, the whole idea of our own contract is that it is only this contract or the owner of the platform that can call this mint function here. That's why we put everything into a modifier, and then we are using that modifier on the mint functionality here. This function is basically helping us to set the platform address, which is going to be the charity. We already have access to this address because we are using this library. And then here we are just returning the decimals, and here we are getting the maximum supply. Total supply and every other thing is still, when you deploy the contract, you see that every other functionality in this is still here. These are just the simple functionalities that we want to change. You understand? That's why we did all these things here. Then in the main contract itself, we are importing the counters library, we are importing the interface that we specified for our ERC20 token, and we're also importing the token itself, our own token gong gong gong, which we'll be using to call the mint function. Then we created the contract. We are using these counters to keep track of numbers. We are yeah, this is the charity token this thing. The charity token interface basically. Then this is the contract, the counters. We are using it as a kind of data type for our current ID, our current project ID variable here. This is the platform address, which is the owner of the platform. This is our struct, helping us create our own specific data type, like combining all the values for every single project. This is our mapping. It maps an ID to a project. I hope you guys already understand the concept of mapping, just like hash tables, mapping an ID to a project. So for every single ID, it's an ID represents a project. So every single ID represents a different project. We have 1 million projects. Number one is representing somebody's project. Number two is representing another person's project. And number three is representing another person's project. Number 1 million is representing another person's project. And each of these projects have different information here based on whoever created it. That is basically what this mapping is doing, helping us do. This is just keeping track of the total number of projects on the platform. This is just an array that is keeping track of all the projects. This is, again, this one is not necessary. You can actually use mapping to do everything in array, or you can use array and leave mapping. It's just that arrays are, they consume more gas. This is platform fee. So if you want to, after getting all the money you want and you want to withdraw, we automatically take this amount of money and send you the rest. So these are our events: project created, project funded, project closed, contributions withdrawn. And this is the function to create a project. Inside of the function, you have all these parameters that you want the user to input. These parameters are also what is going to be filled into this struct here. And parameter, we have some parameters such as image, such as project name, description, goal, start time, end time. We have this require statement. We want to require that the sender, the person calling this contract, is now address 0. We want to require that the goal that they passed in here is not 0, is greater than 0. We want to also require that the start time is greater than or equal to the block or current block of timestamp, and the end time itself is also greater than the start time, right? So we have all these validations here. Then we are keeping track of the current project ID, and then we are now using that ID, which is the number that this thing returns from us. We are using it to serve as the ID for this particular project. Remember what this mapping is doing here. We are mapping an ID to a project. So that's what we are doing now. We're saving it into this variable, and then we are now using it to like populate all this information based on the user input. So that's, the other ones are just extra things to it. So that's basically it for the first functionality. Due to time, I don't know why time is flying. Due to time, we have to carry on. We have to continue in the next class. But on your own, you guys should see how you can. You guys should see how you can do this too, contribute and get all projects before the next class on Sunday. I believe that's all. Are you guys with me?
Yes, we are.
Yeah, we are with you. Please push the code to GitHub and share the link with us. Thank you.
Yeah, I'll share the GitHub
Thank
this
you,
thing.
sir.
Yeah, later. Till Sunday, I guess. Thank you all for coming.
Thank you. Thank you, sir. Thank you, Mr. Chidera.
You're welcome.
Thank you very much, sir. So, don't you go, please? I'm sending you a message, please. I beg. Thank you.
Eh?
I want to send you a message on WhatsApp. Oh, thank you.
Okay, okay, okay.
Temple.